So let us begin with our fourth chapter. So in the last three chapters, we have seen a very quick introduction about machine learning, what exactly is machine learning and all. And then we saw about the programming aspects. We worked on completely about basics of Python and also a few of the libraries. Especially, I want you to recall those three libraries which will be using in projects. And also, we saw about this mathematical aspect. So that is like the statistics. So basically, all the like kind of statistical things like mean, median, and also basic ones, and then we saw about variance, standard deviations, and so on. Okay, so now we will be having a deeper dive into machine learning. So let us dive more into machine learning, and now there are fundamental steps in machine learning which will be following almost for every. It will apply for every model. Okay, so basically, I'll the project if whatever the project we will be creating will be known as a model. Okay, so we'll be creating a machine learning model which will carry out certain tasks to give us few prediction about the future or doing some kind of classification or something. Okay, so for this we have mostly like a standard kind of steps. Okay, so I have generalized over here. So basically first is always the importing of data. So we will be working on a data set, whatever it is. It can be a real-time data. So, but usually in our projects we'll be having a um, fetch data. So usually it might be in CSV file. So we are already seen in pandas, right? So how do we import it? So we will be using a CSV file to import it. And next we will be doing something known as EDA, so elaborative data analysis. So we'll be like applying some kind of analysis. Again, it varies from data to data. Then we'll be doing data transformation. So this would be like something like in the previous session we saw about normalization, right? So we were normalizing the mean value to zero and the deviations like plus or minus one, plus or minus two. So something like that. So data transformation usually would be something like that. Okay, again it varies from data set to data set. And next and fourth is the most important. So that is called as model selection. Okay, so basically there are lots of models which we'll be discussing in this video itself. So we'll have a brief categorical difference. Okay, so over here there will be a lot of models. Okay, so even though almost many of models will apply for one kind of data set, so only one or two or only few particular will be the best fit when it comes to predicting accuracy and all. Okay, so we have to select a very good model over here. So again, at the end of the day, if you are not getting a very good accuracy, so we might need to restart the whole process by selecting a different model. Okay, so when I tell restarting the whole process, might not be till the uh, EDA or data transformation. So if it is the best fit, then it is the best fit, and varies from model to model. So again, with respect to all the models, we'll be discussing in this chapter further down. And next we'll be doing something known as training of model. Okay, so we have selected a model, so we'll train the model based on the imported data itself. Again, we'll be splitting up the imported data like kind of you can decide maybe a large portion, so 70 or 80% of the imported data would be given to training for the model. So basically we'll be telling these are the so and so inputs. So when you have such kind of input, you might expect such output, or you have to predict such kind of output. Okay, so something like that. And after that what we will be doing is we'll be testing the model. Okay, so by this process itself we will be getting to know whether our model has trained very well and how good is the accuracy matrix and all. Okay, so for that we will be getting something known as confusion matrix and all, so accuracy score. Okay, so those and all we get based on the libraries we'll be learning. So then after testing the model you will get certain accuracy. Okay, so after that the final step, so we are not yet done. After testing it, we are gonna go with deployment. Okay, so this is where we deploy into real-time applications. So that is a quick overview of what we will be learning. So we'll be discussing this in detail one by one. So importing the data, so the data can be of various formats and distributed amongst various files. Okay, but usually we will try to deal with one or two files itself. So again, combining them is the one of the tasks that is crucial before processing, so that we won't miss out any kind of data. And next is like many a times data is unstructured, so understanding the flow pattern and converting it into consistent formats is another task that comes under this process. So importing is just not using the library and importing. So maybe we have few more. And finally, data cleaning. So sometimes there are missing values in the data that needs to be taken care of. So there are various of doing so. So basically, you might just check which is blank and just remove that particular row or column. Okay, usually it will be rows. Columns would be a complete feature itself. Okay, so that is about importing of data. So next we have explorative data analysis. So here viewing the data in various ways to understand the structure and understanding how the values is distributed among columns. Okay. So again, with respect to this data analysis, we'll be deeping down. We'll be seeing in detail when it comes to modelings. Okay. So it varies from model to model. Okay. So we'll be giving examples when we go with the types of data modelings. Okay. So next we can use like visual and non-visual methods to understand. So usually we will try to see in both ways. Okay, so as I was mentioning earlier that there is something known as confusion matrix which will be giving accuracy score also. So that will be seeing in terms of non-visual method. Okay, and for visualization we will be using our matplotlib. Okay, the library which we had seen, and also maybe for matplotlib they all the step something would be involved with numpy, and for non-visual also we'll be using numpy, like any for any calculation. Even numeric python sometimes comes under pre-processing steps. Okay, so that is the next step. So before that, the last point in exploratory data analysis is like make a note of all the inference insights and assumptions that you gain or make for visualization. Okay, so basically this will be helping our model to be having a better accuracy score, so a better way to predict the like model predicting the end results for a different data set. Okay, so it is always best like we have to get into what are all insights, inference, and everything that we can gain from analyzing the data. And next we have a data transformation. Okay, so basically if there is any discrepancy in the data type of the column values, or you need to modify the data into consistent format. Okay, so sometimes you need to make different columns values from the existing ones, or remove a few columns as they don't add any information that builds up a model. So basically I was referring to an image processing a couple of videos ago, I guess. So basically, even if you consider this image, you can see there is a lot of blank space. Okay, so this doesn't give much significance to your information. So usually you can remove the probably the top row. Okay, so the pixel over here. Again, if you're not understanding what means a pixel, so basically you can consider a small line to be removed on the top, on the right, on the bottom, and the left. So over here, maybe a couple of lines depends on the thickness. So ultimately, this doesn't give any significance to your image. So when you're doing any kind of prediction or training of model and testing of the model, so these values will not give any kind of information much with respect to the training or testing the model. Okay, so that is where we have data transformation. So maybe another example what I can give is maybe you have two columns. Okay, two columns which will give two different features. Maybe one is the start date, other one is the end date. Okay, some kind of data. Okay, so maybe it is data for finishing of some kind of task. Okay, so when you are finishing some kind of task, you are taking certain amount of days. Okay, so what is the start date, what is the stop date, and you need to predict based on similar the model has to predict different data sets. So how much what would be like again start date, stop date, maybe you have to give a criteria for what exactly would be the start date, maybe immediate. Okay, so then it will give stop date. So ultimate goal is the duration over here. So instead of having a start date and stop date, what we can do is we can just subtract start date, sorry, stop date from sorry we'll subtract stop date from start date. So that is the start date minus stop date, uh, and after subtracting we will be getting the duration. Okay, so ultimately once we receive this duration, so same thing can be given in a single column. So now prediction training of the model is very simple. Certain task, certain duration. So predict me the duration for the different tasks. So that is data transformation. And next we have model selection. So basically this is the step where we'll be going with which kind of model do we need for our particular application for training the model. Okay, so after understanding how the data is and transforming it to the best ways possible for further computation, choosing the model is a important task. Just because it is a complex model doesn't mean it will give us the best accuracy score. Okay, so it is like generally. So we don't start off with them. Okay, so you can try out smaller models, smaller modelings also. So again, in the projects we might deal with a couple of modules. Okay, so again you might be thinking maybe we can use the other model. Okay, so feel free to use those models and check out with respect to accuracy score how exactly you are predicting, and maybe whichever is giving the best accuracy score can be used for the applications. And next we start off with the like basically we start off with the weak models. Okay, so then gradually we move up the ladder. So each model is selectively trained and tested and tuned till we feel that it is the best model that we can use to do on this data set. So again, this varies from for beginner, definitely weaker model to a stronger model, so that you will have a little better understanding with respect to the models. Okay, so some models are kind of complex, so going through all the how exactly the model, the code, or whatever is the library is. So if you are walking down, it would be very hectic. So that's why even in Python we didn't discuss much in detail about models. So there for pandas, for NumPy, even for matplotlib, I was giving just the methods or functions what we can be using with respect to the models. So similarly, here also we'll be having a few of the machine learning models. Okay, so we have few more libraries which we'll be discussing later. So one would be like a scalar. Okay, so most popular one, I guess. So again, it varies. So basically, that is one of the most popular one. So we'll be using such kind of models. Such kind of libraries where it will feature a lot of models. So again, we'll be using that. So after model selection comes training of data. So we'll split the data into training set and test set. Okay, so it will make more sense when we work on projects. So after splitting it, so we'll be training the model. So each and every model is selected, trained over multiple times. Okay, so you can have epochs, so basically iterations. So trained over multiple times in multiple ways to understand why one training set is better than other and why one model performs better over the other model. So again, such insights can be gained by experience itself. So there is no theoretical much aspects which we can just take it as inputs and just create like for a certain data set just deploy or select a particular model and get it. So again, it comes with experience. Okay. So that is about training of model. Then we will be like elaborating the same into test model. So we can only understand how good the model is by testing it. So it's learning on data that is has not been trained on it. So okay, so this will be a data other than training of data. So that's why I was telling like we will be splitting up the data set into training set and test set. Okay, so it will be a completely new kind of data. Okay, and then the training data has been unseen by the model. So again, it won't be completely there forever. So now we'll see how well the model will be able to work on the data so it hasn't seen before. Okay, so basically a new data set. So we'll be seeing how good it is predicting, and definitely we will be having the end results with us so that we can have a comparison with respect to training data set and test data set, or basically the output or the prediction with respect to our test data set. So ultimately we can measure the accuracy. And next is the final step is deployment. Okay, so after being satisfied with the result, we can deploy the model into real world to see how it works on the data from the real world. Okay, so these data again can be spontaneous. It might not be like how we work on our projects. So it will be very spontaneous. You might be getting a real time data, or you can just get data in terms of intervals and get it accuracy. So again, varies from application to application. So the task doesn't end here. So if the model works fine, we try to make it better. So maybe in the steps of pre-processing, so that is like the data transformation, we might end up doing something a little more, which will reduce the features and get the prediction or accuracy up. Or if the model fails to work, then we'll take it we will take it up again. So basically we'll be going through the entire cycle again. So again, it's a continuous process until we get it. So just like how we are training the model repeatedly, so even we have to program basically we'll be working on repeatedly for different models if you are not getting the at least the satisfactory accuracy with the models. And we have types of machine learning algorithms. Okay, so basically these are the types of machine learning algorithms which will be discussed in the next video.